Okay, so oftentimes we'll have two programs or two pieces of software that need to talk to one another, but they may be from different manufacturers or be being constructed on different sides of a company's workflow, and they won't have access to the inner workings of each other, but they will need to communicate in a different way. And to do this, we use what's called an interface between the two programs. Now we're going to cover in the AP subset the most basic form of what an interface is. So rather than go through a lengthy explanation of how interfaces work and what they are, I'm going to give you this example and give you some explanations in context. So we're going to start with two objects. Let's say I have a manufacturing company that makes different objects out of, say, wood, or it will cut them out of wood or metal. I would start with, say, a drawing or CAD program that would draw the shapes that I need first. So by the time my objects are created in the CAD program, I'll have, like, say, a circle or a rectangle. And these are just simple examples. But I have these circle objects. So the circle object is class, and it has the one private variable. It's a double called radius. And we use the radius to actually calculate the area of a circle. So that's why that's the only input value. So the only actual data value here is the radius, and it comes in a parameter. And then we also have rectangles. So we have the same thing. It's but a rectangle has two sides, and the way we get the area is we multiply the two sides together. So we're going to need two private instance variables, side A and side B, and they're going to come in on parameters as well. And those objects are going to get fed to a cutting machine that is going to either cut these shapes out of either wood or metal. So in order to do that, we need what's called a driver. And this is, again, about the simplest form of what a driver would be from software to hardware. And so I would call this one cut driver. And let's drag that into Notepad++, and I'll just go public cut driver. And then I would, public class cut driver. And I'll use a main method here. So again, these are really simplified examples, but let's say I wanted to take a bunch of these shapes that I'm creating in a CAD program, and I want to maximize the amount of wood or minimize the amount of wood that I want to use, and maximize the surface area of the wood used. I'd use this cut driver here, and it would want to first calculate the total surface area of all of my circles and rectangles, or whatever shapes that I do. Well, here's the problem. This is a circle, and that's a rectangle. So what I would probably do is want to add like an array or an array list. Let's go ahead and import Java util array list. And the problem is here, I'd want to create something like an array list, but I got two different types of objects here. So what do I do? Well, the first thing I want to do is a circle and a rectangle, or whatever object or shape that I'm going to build and that's going to come out of my CAD program. They're going to be completely different from one another. So they're not going to relate to each other in terms of subclasses or anything. And all their areas and that kind of thing are going to be calculated in different ways. So I need something else to bind them together. And the best thing for that is an interface. In other words, I need an interface between my CAD program that makes these shapes and my cut driver that runs the cutting machine. So what I do is I create an interface. So I'm going to create a new file, and it's a Java file just like any other, and I'm going to call it cut shapes .java. And I'll pull that in there. And what an interface is as its heart, the simplest explanation for it is it's just a collection of abstract methods and instance variables that you kind of force onto the objects that implement it. So I'm going to create this cut shapes interface, and this one's going to be really simple. You just say public interface and then the name of the interface. So this is an interface cut shapes, and all I'm going to put in here for now is a new method called GetArea. And the only thing we know about GetArea right now is that it is double, and it returns a double, and it is abstract, meaning any classes that implement the interface cut shapes are going to have this GetArea method. So let's go and modify our circle and rectangle class, and we're going to say implements cut shapes, and I'm going to just copy this and I'm going to paste it onto rectangle as well. So I have implements cut shapes on both, and that is going to, if I run this, it's going to give me an error because it is not abstract and it tries to implement cut shapes and it doesn't contain the abstract method GetArea. So same will happen if I do this on rectangle. So I'll get the same error, which means I need to add the GetArea method. Now those are going to work completely differently on each one. So I'm going to go public double GetArea on my good buddy rectangle, and I have two sides here on rectangle, basically side A and side B. And what I'm going to do is I'm going to return the area, which is side A times side B. In other words, length times width, or width times height, or length times height, however you want to think about it. So now if I run that, I get error free except for the missing main method error, which I should get because that is an object class and not a driver of any sort. So same thing, I'm going to add GetArea to my circle. So I'll say public double GetArea, and circle's going to work a little bit differently. It's going to use only the radius and then the formula for the area of a circle, which is pi r squared. So I'm going to return, and I'll say math.pi, which is how you get pi in Java, and I'm going to multiply that times another math function. I'm going to use pow, and I'm going to take my radius and I'm going to raise it to the power of 2, and that's how I'm going to come up with the area for my circle. So now I have GetArea implemented in both of these classes, and you can see I'm error free in both now. So now I want to go back to my cut driver. So this is the essential use of the cut driver. I have these two rectangle objects that I made in or these two shape objects, circle and rectangle, that I made in my CAD program, and I need to take those and interface them with my cut driver that runs my machine. And in order to do that, I have to use an interface called cut shapes. So cut shapes is going to act as the interface here and allow me to add these to my array list. So let's call this cuts, and it equals a new array list, and then we can just add these and keep them empty because we already know what they're doing. So all I need to do here is add a couple of shapes to my array list, and then I can do some interesting stuff. I can say let's use an enhanced for loop here, and I'm going to say for each let's say cut shapes, and then I'll just say shape in cuts. I'm going to print out the GetArea method from that cut shapes interface. So let's go ahead and run that. And you can see it prints out my area. So I'm putting in a new rectangle with 10 and 12. 10 times 12 is 120. And then pi r squared using 5 as r comes out to this. You can check it with a calculator if you want, but that's how it works. But since this is an optimization program of sorts, the functionality that it would probably have would be I'm going to calculate the total surface area of cuts that need to be made, or total surface area of the shapes, so I know how much wood to use in each cut, and I can sort of gauge how much wood I'm going to need to input and how I can maximize my profits and all that. And in order to do that, I would need like the total surface area of a certain amount of cuts. So let's just take the cuts that I have so far, and I can come up with a variable. Let's say double total area, and I'll just set that equal to 0. And then in this enhanced for loop again, I can just say let's also add total area plus equals sh.getArea. And I got to put brackets around this now, since I have more than one outcome that's going to happen under that for loop. I have to enclose them into a bracket. And then I can say system, say total wood needed. I could go, let's go total area, and then let's say square, let's go SQ foot. And then I can run this. Oops, forgot a semicolon there. Try one more time. Total wood needed 198 square feet. That looks about right. Yeah, 120.78. So that's the simplest form of how an interface works. Go ahead and review and make sure you take good notes on that. We're going to cover it in a little bit more detail in our labs as well.